How are you solution? Got it. They are like Christian. Do you need to click? Wait a second. But your things just have more. Yes, my name is Matt. He's got an accent. Trigger. Everybody here. Oh, is this it? Where's right there? You guys have everybody? You guys have everybody? You guys have everybody? Really? When did that happen? I use here. You guys are good? Yes. 1, 2, 3, 4, 5. You have everybody here. 1, 2, 3, 4, 5. Everybody here. Okay, we're missing 2. What does 2 o'clock mean? 2:05? You got control? You do time. It's Fred gave you the instructions on that. Over there. Class. Oh, I can do the clicker? Oh, I can't keep doing it all? We stress each other out. Howdy! Howdy! Come on, impress the SANDIA judges. Try it one more time. Howdy! Howdy! Thank you. Whew! You did it. Can you imagine 4 o'clock on Friday, that you would be here. Video, presentation, physical representation of your solution, i.e. prototype. Dressed up, ready to go. Can you imagine, honestly, everybody? You're all liars, come on. You're all liars, right? Congratulations. You did it. Now, let's finish it. Okay, let's finish it. All right. Congratulations, everybody. You did it. Very good. So, for those that are interested, we are live streaming. Woohoo! Here's the QR code. So, if you got parents, family, the cousin that, maybe you don't like, I don't know. You got this QR code, okay? We are live streaming right now. All right? Okay, I'll let you guys do that. Okay. All right. This is the order of the teams. You all had this last night, but just as a reminder, this is the batting order for today. Quick logistics, as another reminder, I will start with Team Project Faraday. Where are you guys? Right here. You'll be coming on down, right? Price is right. Come on down. You're going to set your prototype here if you have one. And then we're going to set up. I'm going to hand you the clicker. You get all settled in. And the clock starts when we hear the first word. Okay? When that goes to 0000, there'll be a buzzer. And I will stop you. Do not let that happen. Okay? Do not let that happen. All right. Some thank yous. First, I want to thank Professor Brooks. Where's Professor Pafano? Chris Westfall. Where's my staff? David, Liv. Where's some other staff? Cooper. Thank you all. Without your work, this would be impossible. So thank you all. Thank you all for that. Come on, give a round of applause. Students, without the mentors from SANDIA National Labs, this would have been pretty much impossible, right? So much insight, so much help. They've been here sacrificing their time to be here, to be with you. Okay, so please give them a round of applause. Thank you on that. Okay, so obviously we are some logistics here. We're going to start the presentations here. We will get through all of them, and then after that, the judges will probably have a bio break, quite honestly, right? It's been a long time. Then the judges we're going to deliberate very quietly in this room. Okay. In the meantime, students, a couple opportunities here. One, this will be your opportunity to do a survey and also People's Choice Awards. Students, you get to choose most feasible solution, best prototype, best video, best presentation. Okay. And then each student who receives that team who receives that award, each student gets $25 into their TAMU account. Okay? And who remembers the big prizes? Yeah, I remember, right? Yeah, right. 1,500 for third, 2,500 for second, and the big prize of 5,000. Yeah. Amazing how they remember that, right? Really amazing. Okay. One other thing. We are also trying to promote Aggies Invent and the Malloy program. So please, 2 team members from your team, please see Liv right here. We're going to do a quick interview right outside here for Instagram. Help us promote how wonderful this experience was. You notice I give that up. We're going to interview before the prizes, right? But please, it helps us help promote this program, innovation and entrepreneurship. Okay? All right? Okay. Judges, can you please introduce yourselves and say a little thing?
Good afternoon. My apologies, I'm a little hoarse. I got back from Notre Dame this morning. I was gargling quite loudly last night. My name is Krista Jackson. I am class of 95 and 98 mechanical engineering. But at SANDIA National Laboratories, I am the Director of Cybersecurity and Mission Computing and the Chief Information Security Officer. So I am in charge of SANDIA's security of all of our networks, as well as our high performance computing and the transformation of our engineering, the digital transformation of our engineering ecosystem.
I'm Stephen Trujillo. I'm our Deputy Campus Executive to Charisma. At SANDIA, my day job is I manage the engineering R&D portfolio for weapons programs. So all the experimental capabilities, think about wind tunnels, reactors, material science, high compression experiments, and early phase 1 work, but world class. And that's my purview day to day. That's what I do. Thanks.
I'm Lorenzo Gutierrez. I'm the director of the energetic components at SANDIA National Labs. Deal with explosives and power sources for our deterrent. And I'm also a proud dad of an Aggie. My son is entered his sophomore year this year. I want to say you all look sharp. I want to say I know that you're also here competing, but relax, have fun. And sounds trite, but it's true. You guys already won, like was mentioned. So congratulations for being here. It says a lot about you that you invested your weekend to compete, to get dressed up, and to be a part of this. So I'm just excited to be here with you all. So thank you.
My name is Carl Vanasek. I'm also a director at SANDIA. The name of my center is Advanced Manufacturing and Engineering Excellence. I'm also a proud Aggie parent. My daughter Sophie is in the back of the room. Very much. I'm a trained mechanical engineer and a University of Florida grad, so my voice is just fine today. Not a lot of cheering right last night against LSU. But I really appreciate you all welcoming us in, and I'm very excited to see your presentations and the video and models today to see what you all put together. So thank you.
Now with that, we need Team Project Faraday. Come on down. Okay, you guys set up? And put your arrow down this forward. Okay, so let's tell it to the other. Okay. Whenever you're ready, go ahead.
Howdy!
Howdy!
We are Project Faraday, going dark.
On what's being called a massive cyber attack on U.S. government computer networks.
What is being called one of the largest data leaks in internet history.
The laboratory and employees' personal information could be compromised. The company needs to do more to secure its systems.
Introducing the Blackout Box, a simple solution to your problems. The Blackout Box is a modular locker that provides absolute security with its EMF RF shielding fabric that blocks any electromagnetic signals, making sure the device has no connecting capabilities and prevents any side channel attacks from malicious parties. The locking mechanism also provides physical protection from accidental or malicious theft. The easy-to-use fob system allows you to lock any locker and displays your name on the front. And when you unlock it, it turns back into a general locker, ready for the next person to use. The box also has temperature control, keeping your device from overheating or freezing. This is Project Faraday, going dark.
Now imagine this. John, An employee at SANDIA National Labs is required to leave his phone before entering his secure workplace. He leaves it in one of the open cubbies, leaving it exposed to the elements and accessible to anyone. Thousands of employees, like John, are required to leave their phone. As you know, this is because of the 2004 Los Alamos security violation, after which the DOE decided to implement more rules regarding personal electronic devices. As a repercussion, it is now a rule for all SANDIA employees to leave their phone before entering their workplace. The lack of a locking mechanism on the cubbies is a problematic issue because it allows for anyone to take your phone, whether intentionally or by accident. This leads some employees to leave their phone in their cars, which causes the issue of overheating, which can lead to battery degradation. That leads us to the heart of the problem. The current cubby storage system is highly unsafe, thermally inefficient, and cumbersome to use.
So, why should you care? Well, if an employee were to bring their phone into a secure location, because, maybe they forgot, didn't want to use the cubby system, that would leave y'all susceptible to a security breach. Now, even if that phone is turned off, we have found that there's signals that are still being sent from that phone. So the microphone can still be hacked and it can listen to your secure conversations that are happening. Employees don't use the current system because it is hot, unsafe, and requires several steps to disable telecommunication. And because of the differing storage systems that are around your area, it can lead to an increase of human error, the enemy to security. And as you may know, these security concerns can lead to a loss of trust between departments. And one big accident can cause a huge damage to your reputation, leading to a loss of funding.
So, how do we fix this, you might ask? Well, introducing Project Black Box. This is Project Black Box. So, it is constructed out of durable stainless steel. On the inside, it's coated with an EMF resistant fabric. So it's a nickel alloy, so it is resistant to all types of Wi-Fi, all electromagnetic waves, Bluetooth, all of the like. It's very easy to use. So you simply take out your phone, put it inside, shut the door, and all electromagnetic signals are blocked, incoming and outgoing. Now, once the door is shut, it activates our cooling solution, which is a thermoelectric cooler. So what it does is it can heat and cool the box to be able to allow it to remain temperaturely consistent, which prevents battery degradation. Because, of course, as you know, phone batteries don't want to get too hot or too cold. It's very easy to lock and unlock. So you just take your fob, right into your personal fob, you simply scan it onto the RFID scanner. What the RFID scanner does is it allows you to use any of the boxes across the entire facility as your own temporarily. It registers your name on the front, John Black Boxes, and then at the end of the day, your fob is lit up red to remind you your phone is still inside of a box. And to just release it, simply have it back. And you are free to take out your phone and replay. You don't have to turn back on your phone. We enable Bluetooth, all the simple things that make it a hassle to put your phone in the box and why you would want to leave it in your car. The goal of the Project Black Box is to make your life easier. You actually want to use the included cooling solution, the included storage solutions at SANDIA Labs.
As we've just demonstrated, the product, our black box solution, it works. It's efficient. It's effective. Perhaps most importantly, it's economically and sourcefully feasible. These materials, we made sure to source were common materials, stainless steel. The Faraday fabric is woven copper and nickel. These are in abundance. We can start mass producing these today. There's nothing stopping us. The thermal control aspect can be used for those in more harsh environments. For instance, if you want more extreme, robust cooling options, the modularity allows us to integrate passive and active solutions to cooling. Think heat sink, cooling fan, insulation. It's by design. We can make it to suit your needs. These are going to run for about $40 we can offer. And we can also do, like, again, it's modular and scalar to suit your needs. But for reference, a 60-unit storage system is going to be about $2,500. What does all of this add up to, you might ask? Well, it's easy to use, first of all. It's simple, straightforward, and it enables fast operation. It really does just work at the click of a button. And plus, the thermoelectric cooling makes it so that it's virtually has no moving parts. You don't have to worry about any fancy hydrofluorocarbons, typical of a compressor system, perhaps. It's environmentally safe, and this is available today using our technology.
The impact of our product is clear to see. It safeguards against espionage from malignant attackers. It extends your personal device the lifespan of its battery, and it does this all seamlessly and effortlessly. Hi, my name is Karun. I am Chief Information Officer. I specialize in electronics and in automation. And fun fact about me, I grew up in LA.
My name is Chris. I'm the head of research and development. I'm responsible for heat transfer and thermal control of the product. Born and raised in Texas, go Dallas.
Hi, my name is Cameron Schultz, and I specialize in control systems, and I love tinfoil. And Miley Cyrus.
Howdy, I'm Priscilla. I am the audio and visual director of this presentation, and I've got 10 plus years of video editing.
Howdy, my name is Louise. I am the senior marketing manager. I'm a 4th generation engineer, and I chose the song. Thank you for everyone for listening. Thank you for all our mentors, our SANDIA mentors, for giving us our secondary research. To our Aggies Invent staff for helping us improve upon our presentation. And lastly, to the judges for listening to us. Thank you. This is Project Faraday, Going Dark.
Good job, Project Faraday. Judges, questions?
Do you think on the system that you'll design in order to log in, establish your identity, perform the thermoelectric cooling, it seems like it's wireless, maybe Bluetooth. But did you consider that you're introducing vulnerabilities with that system, right? That's then outside of your protected RF area?
Well, we plan to make that system not only air-gapped, but it doesn't have to be necessarily integrated with much more detailed system, like such as your own business and operations. You can just upload that data server separately, and it only contains names and IDs, perhaps. And it just keeps the phone secure, and perhaps a few other devices.
Thank you. Talk to us more about your cooling technology and what are the power requirements for a set array of an installation?
So,
Okay.
I'm sorry.
Oh, sorry. Yeah, you can put it to. We actually have an appendix on that. Go to appendix. There we go. So the thermal control. These thermoelectric coolers they basically run on just electrical and using semiconductors. You can actually operate them in a reversal mode by just reversing the polarity. So it not only works in hot environments, but cold. It can keep your devices warm enough to operate if that's also a problem that you may encounter. The operating requirements it's approximately a power input of 50 to 60 watts. And the coefficient of performance of such a cooling device is going to depend on a variety of factors. But I've got a quick demonstration of why we care about it, the solar radiation aspect, and natural convection, and what heats up the phone. And just to give you a frame of reference, after 10 minutes in a 45 degrees Celsius air temperature, which is about 115 degrees Fahrenheit, your phone will already increase temperature by about 10 degrees Celsius. That's enough for it to already be considerably hot and overheat. These are low voltage applications. It shouldn't be anything too crazy. And again, the current is also very low. Doesn't pose too much danger or risk, especially considering there's ground faults and other things already in place to protect you from that.
So, as you chose the materials you did, recognizing they're outdoors in Albuquerque, which we get monsoon season, rain, hail, other things. When you think about stainless steel, copper, how are you thinking about positioning that to weather the elements?
So the copper and nickel is in the Faraday fabric weave, which is all contained inside the lockers. So the lockers are shut; they're just not necessarily locks. There's a latch. So the lockers would be shut, and the copper nickel alloy in the fabric would be exposed to the outdoor elements. Stainless steel could be painted, of course, and have other treatments applied to the outside. So weathering over reasonable amounts of times compared to the building, compared to the other things on and around your facility, wouldn't be any more at risk than anything else.
I guess that's what drove you to stainless steel specifically as a solution.
Well, the stainless steel is pretty much an ideal choice to protect against rust due to its anti-corrosion properties. That's already sort of being used in current storage solutions. Stainless steel is an option that we found based on our own research. And so we thought, why not just build on top of that, but add these additional layers to improve the design.
It also does add to the thermal mass. So it does make it heat up and cool down, so that it helps with that. And allows us to potentially put the hot side on the actual wall itself instead of to have a cutout or some other method to make it.
And where does the power come from to run the system?
The power could come from an external battery or generator. It's really up to the specific use case, depending on if it's a corporation or government facility or national laboratory. But it should be able to be easily incorporated into the current infrastructure.
All right. Thank you, Project Faraday. Thank you. Okay, team, DC capture, come on down. Clickers on the table. And the down arrow, so you see the down arrow, that goes forward in the deck.
Gotcha.
Okay.
This one goes.
Okay. Let's wait for the judges. Let me know when you're done. Good. Okay. Whenever you're ready.
You are the last line of defense between the classified and the compromised. Every word, every page, every decision matters, but the system isn't keeping pace. Manual redactions, volunteer workloads, constant pressure, security, or speed. A choice no one should have to make.
The Pentagon is investigating what it's calling leaks of national security information.
Over 1 terabyte of highly sensitive military data, including nuclear submarine weapon software and top-secret combat systems, has been leaked online.
We built a system that supports you, not replaces you. Because you deserve tools that defend as fiercely as you do. A smarter system for smarter security. Our tool uses intelligent document analysis to assist classification decisions, suggested redactions, simple approvals, Secure, auditable workflows designed to reduce stress, improve accuracy, and keep pace with demand. Because in national security, confidence is everything. We want to defend you so you can keep defending us.
You wouldn't compromise national security over efficiency. So why choose? Shouldn't managers, especially in this day and age, be able to do both? Howdy, we're DC Capture and we're excited to promote to you our modern day solution.
Picture this, classified documents only meant for your eyes gets leaked. Secretive information, assets, all out in the open, and suddenly, it's a national security issue.
This is a hypothetical scenario, but it is very true, especially considering the amount of pressure that DCs, that is derivative classifiers, are under. Mistakes are no longer a possibility. They will actually happen.
That's why we're here. DC Capture provides a solution to your problems.
The problem is, current classification review lacks modern innovation, which drives both efficiency and security. Our national defense system can't risk delay, but it also can't risk mistakes. We need a solution that drives both efficiency, and helps our current solutions. We want a system that helps humans, but doesn't completely replace it. Something that understands the team's need for speed without compromising security. Our solution is the unique combination of all of these qualities. Overall, we aim to build on existing infrastructure, minimize the classification leaks from high side to low side, and then also expedite the DC review process.
In our primary research, we identified 5 design requirements that are necessary. Their confidentiality, through data integrity, availability of the application, the speed of the application, and finally, its feasibility into your current systems. First, we attempted a browser extension, but of course, as you know, browsers are highly inconfidential. We need to make sure that this is the priority of our solution. Next, we potentially looked at a script, just a simple programming script that you can run on any device within your company. Unfortunately, though, this also presents issues with availability and feasibility, as Python file has to be on everyone's device. And now we have to make sure that device has the flash drive booted up. So we came up with DC Capture. This thing meets all of the criteria in our design requirements. After further research with your engineers, we came up with a few features to present. The first one that we're proud to present is the Intelligent Flags system. Your current system optimizes flag placement by the submitters to your DCs, derivative classifiers. This builds on top of that and makes sure that your flags are confidently scored, and addresses that potential miscommunication. Next, secured views. We need to make sure we separate the submitter from the DC. You have certain certifications to view classified information. We have separate views to make sure that's maintained. Finally, the integrated file share. Your current systems have the documents already stored. There's no need to make an external redundant data source for those documents. We'll use what you got, and we're implementing the solution for you. I'll hand off the prototype over to Jake.
Thank you, John. So now let me show you how that all comes together in our prototype. So it starts with a document that needs its classification level confirmed. This document is submitted to our queue system, and from this queue, derivative classifiers can pick a document which they would like to make a classification determination on. But we built further than that. Our queue can smartly assign these documents to derivative classifiers based on the document's subject matter and the expertise of the derivative classifiers in order to remove the guesswork from deciding which derivative classifier to send these documents to. However, we have not removed the manual assignment in case that is necessary. Now, before these documents are distributed to the derivative classifier, they go through a couple more steps first in order to ensure that the derivative classifiers are able to efficiently and securely review these documents. First, the submitter themselves will add flags where they think the derivative classifier should pay extra attention for a potential infraction with the classification guidelines. Next, after they've added those flags, the document will go to the DC Capture AI. Now, this AI will compare the document with the classification guidelines and add flags where the derivative classifier might want to pay more attention to those sections as well. And then finally, keeping the human in the loop in order to ensure absolute security and that the final determination is made by a person, the derivative classifier will be able to modify, add, or remove flags accordingly in order to ensure that the correct determination is made for the document. After this is done, it will be sent back to the submitter so that they can make revisions until the document is correctly classified. So now allow me to show you what this actually looks like in our workflow. First, the submitter will choose which clearance level they're going for and then upload the file using our UI. They can add some brief specifications about the file and then submit it. On the right, they can monitor the status and then review feedback from the derivative classifier. From the derivative classifier's point of view, they'll receive the document in their queue and they can select it to start reviewing it. Our smart PDF viewer will show them the document along with visually showing them where these flags have been indicated by both the AI and the submitter. They can jump around using the flag validation dashboard on the right to quickly move between these areas, and then they can confirm, reject, and add flags accordingly until it's been corrected. Finally, they'll submit this review so that the original submitter of the document can make the necessary revisions. And so that's what it does. Now, here's the impact. Karina?
Thank you. So DC Capture aims to support your DCs. We want to keep them in the loop as an end reviewer, taking out the middle haystack. DC Capture also reduces the time spent reviewing the entire process with instant flags and quick queues. DC Capture also boosts national securities by reducing any errors made on our parts when we are really tired with a lot of workload. DC Capture also scales. We scale with you. As you develop, we develop. As you grow, we grow. We're an application made for you. We also reduce the workload and the stress on your workers, an important part. We make it more efficient, more beneficial, reducing the workload overall. Thank you so much. I'm Claudia. I'm a first-year mechanical engineering student.
My name's John. I'm a computer science master's.
My name is Jaden. I'm a computer engineering second-year student.
I'm Justin, a junior data engineering student.
I'm Sarah. I'm a sophomore chemical engineering student, and together we are DC Capture, where you no longer have to decide between national security or efficiency. Thank you for listening. We are ready to answer your question.
Judges. Sure, I'll start. Great presentation. Curious to see what's required to actually train the models, and is there any loop around to make the model more effective every time determinations are made by an actual DC, just that continual improvement of the model?
Yeah, of course, I can answer that. The AI model that we chose was Grok API. Now, their infrastructure required is consistent with the modern API endpoints that we see for submitting submitting documents to an AI for any type of review. To make sure that model is trained, we've heard that you have implemented models and run those things locally in a secure network. Because we chose such a simple API framework, we're able to introduce your model directly with ours. And because we have been logging these DC classifying reviews, we can implement that data stream directly into your model and train a model based off of that data.
What's the retraining or update time that's necessary as classification guidance is updated or changed or new guidance is released? How do I push that into the system, and how can I be sure, or when can I be sure that the AIs that flags it appropriately based on current guidance?
Of course. To answer that, that's really a case-by-case basis, and depending on your engineer that is reviewing those project specifications and the classification guideline, we would love to work directly with those engineers and make sure that communication's there and how that timeline needs to look, because it can be different for each type of model that's out there. Does that answer your question?
Yeah, I think so.
How much did you make an estimate of how much would cost to create it and then to sustain it?
Yeah, so we'd work with you in order to determine the best plan to roll this out, since it would be a scalable model So we would start out by rolling it out to several derivative classifiers and then asking for their feedback. And then after that is done, we'll get feedback and iterate on the model until it's deemed very user-friendly by them. And then we will move to roll it out to the entire workforce of derivative classifiers. And at that point, we would be running it locally on your servers. So most likely, it would just require the attention of your IT staff, which you already possess, and we would work with you in order to integrate that into your system.
Any more questions?
On an earlier slide, you mentioned Smart Assign, and I don't know if you returned to that. How does Smart Assign work?
Yeah. I would take that. Yeah. So what the Smart Assign does is it'll use the language model to analyze the document, and then we'll also have a bank of we'll have a database. We with our primary interviews with your employees, we found that there was a database for derivative classifiers, and so what we would do is we would take the document subject matter and then combine that with the database of derivative classifiers and use the language model to match this document with derivative classifiers in order to make correct assignments.
So as you were making those assignments, there are times when, for example, we're out of the office, maybe in Texas A&M judging an Aggie Invent. If we were to be assigned, we wouldn't be able to get to that item. Had you anticipated an alternative, what to do if there was an urgency on something and someone was assigned?
Yeah, that's exactly right. Actually, we had a conversation with the SANDIA employee who was saying that whenever they submitted their presentation to your review, the person who was supposed to review it was going to be out of the office on vacation for a week. And so it ended up not working out very great. So yeah, part of our system is on the interface. Yes, there is the Smart Assign feature, but a submitter of a document will be able to manually go into the derivative classifier database and choose employees. And there will still have to be some back and forth communication because, as you know, this role is somewhat volunteer based. So there would have to be some back and forth communication. And if there is an issue, then the derivative classifier would be able to indicate that they're unavailable for this particular item at that time. And then the submitter could pick a different derivative classifier manually in that case.
Okay. I think that's it. Very good. Thank you, Team Team Remote Trust. Come on down. Down arrow. Makes it go forward. Okay, down arrow. Right. Oh, ease off there, cowboy. I want to make sure the judges are good. We're good. We're good. 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 Let these guys sit down a little bit. There you go. I appreciate it. Really, I do. Okay, I think you're ready. Go ahead.
Howdy! We are Team Remote Trust, experts in information security with expertise working inside of national laboratories. We're here to bring the security of the office anywhere. Oh, yeah. That doesn't work. No! That can't happen! Welcome. Oh, you can't even do this?
Okay, so in the video you just watched is Adam, one of SANDIA's brilliant minds, and he's the only expert who is working on a highly sensitive and a mission-critical project at the moment. He receives a devastating call from his family, and his wife is terminally ill, and he has to stay at home and take care of his wife. Currently, SANDIA's remote work policies do not allow him access and or even to contribute to the project remotely due to the classified nature of the project that he's working on. So then he's forced to choose between his family and his mission. Another employer offers Adam a role which has a flexible and remote secure option. So then he takes a difficult decision to leave SANDIA and then move to the new job. So then what happens is that the project is now paused indefinitely, and training and new replacements is going to take a lot more time, and then it's going to cost SANDIA time, resources, and then momentum, putting national security and advancements in scientific advancement at risk.
Yeah, so could go to the previous slide. We hope you enjoyed that story. So clearly inflexible remote work policies are delaying projects and can be costing SANDIA talent. And to come up with a solution to this problem, we developed a framework of 5 different design requirements, the first being legal. So any solution that we had to come up with had to follow the bounds of the law. It had to be secure. So when an employee is working remotely, we have to avoid any sort of data leakage. Our solution has to allow the employee to work off-site. So they'll be able to perform the work like within the comfort of their home, or if they're not able to come to the office because some emergency happens, they need to be able to do that. Then fourth, it has to be compliant. And what that means is it has to follow all the policies that SANDIA has outlined for the employees. And then lastly, it has to be timely, meaning that employees should be able to complete the work with at least the same efficiency that they would be able to if they were working in the office. And the first solution we tried to look at was creating secure facilities, which are essentially like remote hubs where remote workers can commute in to do their work. But we found a number of issues with that. First of all, it's not off-site really. It's not true remote work because employees still have to take the time to commute to an office. And because of that, they lose out on some time and productivity. The next solution we looked at was Faraday homes. And our idea with that was to convert the entire person's house into a secure facility. So we plan to shield the entire house in a material that would block any sort of electronic communication from happening. But there were some issues with that as well. First of all, it's expensive. Not every employee is going to be able to afford to have that installed in their house. And also, whenever the employee leaves with a device, there's a possibility that like some data could be exfiltrated from that because they're no longer inside of the Faraday home. And so then we thought, what if we were able to put that security inside of a single device? And that's when we thought of the remote trust. And basically this thing checks all the boxes. The only thing left is legal compliance, which we believe that based on specifications of our product, the law would be, it would be easier to get the law changed in order for us to be able to provide you guys with these devices and for you to be able to use them in production.
So, introducing our solution, the remote trust laptop.
I'll go ahead and present this.
This is a fully air-gapped device, meaning that any information on the laptop cannot be accessed other than with the device. And it's still a laptop. Any approved SANDIA software programs could be applied to the device before the employee took it home. So whatever they need to do, running simulations, running data analysis, an employee would still have access to it. And additionally, we've incorporated multiple security systems, both physical and digital. In order to access the device, an employee will first have to put in their badge and password. While signing on, multiple passive notifications will be given to remind them, hey, do you have any personal electronic devices in this room? Do you have any AI Alexa type assistants? Just to ensure compliance. Additionally, it comes with a tamper-proof seal that if anyone tried taking data off of the device, it will note that this happened and will wipe any existing data to ensure that data stays outside of our enemy's hands.
So the impact of our device. Essentially, it will prevent project delays. Like our story with Adam, it will allow Adam to be able to work remotely and finish his project on time and efficiently, instead of having to wait until his wife is healthy or he could go back in person. And so with SANDIA's 2023 strategic plan, they had the hypothesis or the strategy to achieve 30% hybrid by 2028. With this device, it will allow them to achieve their goal of 30% hybrid remote work. And also in the SANDIA 2023 strategic plan, they received triple the qualified applicants for a hybrid approach, like jobs, compared to like in-person work. And so it went from all the way from 100% to 200% more qualified applicants. Overall, this product will allow future-proof the workforce as more companies want to improve the remote or hybrid approach. The technical feasibility. So Remote Trust uses existing computer parts that are readily available in today's market. And so it's super easy to construct this device with technology or hardware that is used today. Remote Trust will also be partnering with SANDIA labs or other national laboratories or even the military and making a customized data security system where they'll be making their own hardware and software in-house for whatever needs they may have. This will help with putting on their own customized security solutions in the devices that they need, whatever software they need or whatever work documents they need.
So now we'd like to talk about the comparison with existing government laptops and our device, which is the Remote Trust laptop. You can see the price is marginally higher than what a typical government laptop would cost. And that's because of the additional security features that we have. And you see it's fully air-gapped. We're developing a custom operating system.
Do you guys have any questions for us and our device?
All right. Thank you, team.
Help me understand how you will download the data that you need onto your laptop and the secure data structure you're talking about, yet have an air gap solution. I'm trying to bridge that.
So we are going to have a custom data port that only would be accessible on SANDIA properties. So this port would be plugged in and allow the employee to get whatever relevant, classified, or sensitive information they needed in order to successfully complete their work remotely. Before the device is taken off-site, some tamper-proof seal will be put on to ensure that no data can leak.
What was the biggest challenge you guys had as a team coming up with a solution?
I can take that one. Yeah, so the biggest challenge that we faced was really refining the problem statement and understanding what our design requirements were going to be for this. Because obviously security is a really big issue, and even security in remote work. And So we just wanted to be able to tackle one part of that in our device.
I really like the login asking you about Alexa devices because they're so prevalent. And I think we have to ask that. We have to do that now. We're at the start of a Teams meeting. We have to make sure that people don't have an Alexa device listening. So I think that's a great idea that we can do that.
What do you envision what do you envision the primary use of this for? For something like data analysis, for something like administrative functions, for
I believe this is something.
The sweet spot is.
I believe this is something we would have to work with Sandia to understand where the level of security comes into play in terms of what is or isn't allowed. Because currently, you guys aren't able to take any classified or sensitive information home with you. So identifying what that sweet spot of, hey, I'm coming to Texas A&M because I have to judge a competition, but I just put in some classified technical document that needs to be properly reviewed. What if there's an issue on this document and only I can change it? If you're here, the work is delayed until you return. We're hoping that this will help when employees have to travel or when life happens and they just aren't able to come into the office.
Is there any monitoring on the device itself so you can keep track of it no matter where it is? How's that?
No, there's no monitoring at all on this device because we think that's a security concern. If there's GPS or I guess like monitoring like activity on the device, I think that could be easily like penetrable in a sense. And so I think it's up to the employee keeping sure that the device is with them at all times, making sure they're in like an enclosed room without any like security breaches that are like prevalent in today's society. And so adding like I guess software to the device is not very practical in like a confidential environment. And so that's why we decided not to have any like security measures where they're monitoring what is happening on the device.
I mean, like even just GPS. Is there any tracking of the location of the device? Okay. Thank you.
Kind of related to that, you'd mentioned that what I heard was that the device would sort of sense tampering, would invoke some penalties on itself. Do you feel like that's there are mature solutions available for that, or is that something you want to develop more? Did I get that right first?
Yes. I think this is something that we would have to develop a little more because obviously this is very secure information. We don't want leaks, but we need to understand what's the difference from, oh, I dropped my laptop or something fell on it versus I'm intentionally trying to open it. So we would need some further analysis to find what that point is.
One last question related to just because I'm curious for your management on this. On the self-tempering aspect, is there any like self-destruct that physically happens or is it all software?
I can answer that one, yeah. So right now we don't have any physical self-destruct, but when tampering is detected, it destroys all the data, like it overwrites all the data on the disk, so that it's just completely unrecoverable.
All right. Thank you, team. Team Farracom. Lots of Faraday, Ferris. Yeah, Ferris. This is and we were first. That's Ferris. Yeah. So it is arrow. Arrow down goes through the deck. Okay. All right. Judges, are you ready? Okay. Ready? Team, go ahead.
Farracom Solutions. Stay connected, stay secure.
This is Joe. Just like Joe here, an average day of many SANDIA employees involves waking up early, driving to the SANDIA National Lab, and locking up their phones before they leave. After that, Joe goes to work, and he can only access his phone after his day is over 9+ hours later. He constantly misses a lot of things. Some of them can be as important as this one. After this event, like 8 hours later, he can finally get to it. Are you also worried about what you will miss? Introducing Farrakhan Solutions. Imagine employees who keep in touch while keeping the security of the high-stake laboratory uncompromised. This is exactly what the Farrakhan pouch offers you. Our pouches use existing Faraday-backed technology to block all RF signals. But we have taken that and upgraded to a next level. You can receive signals and you can know what's happening. You can receive next so that you know when is the right time to step out.
How secure is your lab? That is one of the main questions that we asked ourselves this weekend. And the one thing that kept coming to mind is that companies with secure areas, with secure labs, they do not allow personal electronic devices, otherwise known as PEDs, in the labs. And hence the no phones. And so one number that came to mind was the number of employees at SANDIA. And that's 16,900 individuals. 16,900 people are affected by this protocol. Now, you may be asking, Chesney, that's my name by the way, Chesney, aren't there current solutions already for this? Well, there are, but they are not long-term or feasible. For example, one of the options is you can keep your device in a secure area inside the company. Another opportunity is to keep it in your vehicle, but then that arises the issue of temperature. And then the third solution is just alternative communication overall. Now, ultimately, working at a secure lab, because of these restrictions, can sometimes be inconvenient for the employees and even mean that they're disconnected from life in general. And we want to make this not happen, essentially. So that's where we come in.
Okay, so now we talk about the ideas. So basically, these are some of the initial thoughts that we had about the product that we should make. So if we are to look about over there, the first idea that we thought was make a software program. But yeah, software is easy to make, but it's not private. SANDIA employees would have to give entirely complete access to their software, and basically the company would have access to their personal emails, chats, so on and so forth. And software is not modular. Let's say Apple, Samsung, no one would allow us to, tamper their operating system. That itself is a security hazard. Going to the next thought that we had, basically we did a pivot to hardware. We thought about docking stations. So in docking stations, the hardware would be tamper resistant, yes, but they are not convenient. The employee would have to carry a device given by the company and then connect it to the table, basically which has a docking station, and they are stuck to the table. So it's not portable, it's not energy efficient, it requires a lot of energy, and it's not private again. So what next? How do we solve the problem? Soha will tell us how we are proposing to solve the solution. Yeah.
So introducing the Farrakhan Secure Bag. So this bag solves the problem of you having to leave your phone out. Where do I leave my phone? On locker, car, vehicle? No, you keep it on yourself. You can keep your phone on yourself. How? Simple Farabag technology. We use Farabag tamper-resistant technologies that block all kind of RF signals from coming in or going out. So yeah, then you would wonder, sure, nothing comes in and goes out. Why do I need a brick on me? Why do I need to carry a brick on me all day? Well, the thing is, we've thought about it and we've added another layer to this. We allow incoming signals using antennas, which my teammates will explain. So you can receive all of your notifications and you can view them. So when you find out that something important happens, you know when to step out and not ignore. So going on to explanation, the impact of our product. Now, this impacts all of our SANDIA employees, all the 16,000 people, all different labs around the world. We can expand around the world in different labs. Of course, military is an obvious way. There's been incidents about phones and soldiers across, especially in the Eastern Hemisphere, where soldiers haven't handled their PDs appropriately. These devices could solve that. Finally, personal. You're a VIP, we got you.
Okay, so you may be wondering, how does this work? Our pouch consists of 5 layers. This is also a neck brace. You can keep it on you, put it on your neck, keep it with you in the lab. So 5 layers. The first layer is the outside fabric. The second layer is this one simple antenna to keep the signal from coming in. Then we have an insulation layer. That goes between the antenna and the aluminum mesh layer. The aluminum mesh layer keeps signal from going in and going out, other than the signal that comes from the antenna. And then finally, we have a layer of fabric that goes on the inside to keep your phone safe and secure. Now, if you have an aluminum mesh layer, how would you be able to see like the notifications on your phone to know that you got an emergency call? Faraday fabric, that's transparent. It's the same as the aluminum mesh layer. It acts the same, keeps the signal out, keeps the signal in, so you won't have to worry, and you can still see your phone screen. Now, you may be worrying about the camera. The camera, we have a one-way film underneath the Faraday fabric. So your camera can't see out, but you can still see in. And then under that, if you want to tap your screen, you have a slightly conductive film called the PETG film. So you can tap your screen and it'll light up so you can see all your numerous notifications.
So the framework for this is quite unique, as we are implementing a solution that is not out there already. Because our solution requires internet access to receive your notifications, it becomes a security risk, as internet access is known to transfer both in and out. So for our solution, we decided to focus on just receiving notifications, just receiving what is happening outside the world. You don't need to contact the world, just keep it in your pocket. So we did that by physically attaching an antenna that is unidirectional, only incoming Wi-Fi signals. The Wi-Fi would be set up in a peer-to-peer network isolated from the outside environment, and it would be supplied by the already existing infrastructure of your company or provider, which I assume you guys have. We also have the antenna connected from the phone via USB-C, so it's mostly compatible with all new devices starting last year to the future, as it's become the standard. There's an example image at the middle that just shows that we can connect the internet into the already existing infrastructure for secured network using your own firewalls, and then we can distribute that information or Wi-Fi signal to the employees without them having to send any information out. So the main hardware components of this that allow us to be unique is the USB-C antenna, an antenna that can only receive signal, and it's able to transfer analog signal into digital signal so that the phone can use the USB-C to transfer the information. The micro speakers are to prevent the microphone within the phone to record outside conversations by blasting a bunch of frequencies. And the breakdown.
So lastly, there's so many layers, so many components. How much does this cost to make? Okay, materialistically, this costs a whopping 40 Washingtons. Okay, so 40 Washingtons. That's one per employee to stick their personal device in and keep them with it all day, so that they are able to stay connected to their family, and so you can keep your company safe. Thank you, and we are Faircom Solutions. My name is Ishika.
My name is Elisa.
Soha.
Dwight.
And my name is Chesney. And it was great speaking to y'all.
Thank you.
So if I get you straight, you're solving the problem of like basically from making your phone into a one-way pager.
Yes.
Would you guys consider potentially having software on someone's phone that would just look for important messages and either forward to someone's email or to a pager?
We did think about that, but there are security risks within the software itself. Are you talking about a local, like we install the software,
As
or
opposed to like all the hardware associated with trying to carry this with you, just so you can have insight into important messages that are coming. Having a solution on the phone that perhaps just either forwards to a one-way pager or to someone's email or desk phone.
We did think about that. That was one of our first solutions, the Lockdown OS. Similarly, it has issues that prevent it from being implemented securely, as the OS can be compromised if not upkept. Different OSs and different phones are available, and security within the data itself. Like, what if your phone is already compromised?
I'd like to add on to that. So, of course, we will be depending on the Wi-Fi and the SNL networks provided in your facilities, and essentially how much data we get is dependent on your facility's Wi-Fi. We could also alternatively set up our own SNL networks, which should take about a year, according to many of our research, which would give us the one-way data that we're looking for through our connections. We have appendices if you want to go on about that.
I like the way you thought of all the different features on the phone, right? The camera, the microphones, and protecting all of it. One element of the transparent Faraday cage, is that something that exists today?
Yes, it does exist. Do you want to go to the slide with
You can talk about the microwave.
Yes, so we actually did a lot of research into this, and they do have a Faraday fabric that is transparent. It's 89% transparent. To make it more secure, you can add 2 layers onto it, which, like, you can still see your phone. It's super easy, and you will only need to see your notifications because you won't be able to send any outgoing signals. But yeah, it's fully transparent. We'll have like a black cover at the top as a hardcore block for your camera. But in case your camera's just a bit smaller than like that cover, then the one-way film will be popped right in there just so you can't see anything out.
Yes, everything already exists, so there's no manufacturing issues with it.
We are just combining a lot of
elements
into a solution.
Really good. Really great. For your cost estimate, did it include? You wonder about the total production volume. Is it $40 if you're making $1 million a year, or $40 if you're making 100 a year?
It's $40 per unit. So per bag is $40. I did it based off of bulk buying. So I a whole bunch of stuff. I divided the area by it.
It's the material cost.
Yeah, it's the materialistic cost. So not really production costs, but I could probably make this like myself. It would just need some like gluing, some taping, like it's pretty simple stuff. Just to, like sew it up in there and it'll work.
Easily flip back to your budget slide.
What's powering this speaker?
So the speaker is actually a combination with the antenna. There is an adapter for it, which is
connected to the phone.
Because USB-C is brilliant, and it transfers audio, video, power, and data at the same time. So we're actually using the power from the phone itself to power the antenna and subsequently the speaker.
As you consider the enclosure for this, how are you going to close it and ensure it's properly closed so you don't end up with leakage?
I can answer your question. We did think about that, and we actually implemented a mechanism that unlocks the top of where you put your phone in, right, via magnets. Now, this mechanism is commonly seen in stores when you buy or purchase clothes, the security tags. Similar system, a little bit more tamper-proof, a lot more actually, and easy to use. Lock in, lock out.
Very good. Thank you, Team Fair. Thank you. Team Take Back. Come on down. Pushers on the table. And the down arrow is how it. Down arrow goes forward in the deck. Got it? Hold on a second.
Howdy!
Howdy.
Whoa, 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 whoa.
So okay. Wait, let's let this team sit down real quick. Okay. There's one. Okay, when you're ready, please go ahead.
Howdy, we are Take Back.
Okay, yeah, Nitya. Do you think you could get done tomorrow or Monday?
Yeah, I can definitely get that done. Maybe not tomorrow, because tomorrow I'm working on Project X, but
Isn't that classified?
I'm working on Project X.
Like 68% of data security breaches are caused by human error. We need to mitigate this. This is why our problem statement is mitigating unintended network-based transmissions caused by human error.
We wanted to approach this problem statement first through our customer interviews, i.e. real SANDIA employees and their real concerns, and our research. And we determined that there's 5 key design criteria that any solution that we wanted to develop had to meet. First is data protection, first and foremost. As you know, in SANDIA, classified information needs to be protected, and you're well all aware of that. So security is very important here. Second is non-invasive. It can't be a hindrance to when you're working. It has to be seamless. Third is customizable, whether it's the user or it's the company, SANDIA. It has to fit to your use cases, so it has to be customizable. Performance can't slow you down. Simple as that. Finally, deployable. This means, one, that it has to not be a hassle for y'all to get this working for SANDIA or any other company. But it also means that it has to be able to use across a wide range of devices and apps.
Using our problem statement, we created 3 potential solutions. First is a software-based AI speech card. Second is the AI network sniffer. And lastly, a hardware-based USB audio microphone that takes an input and uses AI to externally filter this.
We compared all of our solutions with our key design criteria. And we don't want to focus on which ones didn't meet it, because the one that did meet it, which ticks all the boxes, is the solution that we decided to move forward with.
So, our software has security and deployability, and these are 2 big pieces of criteria that we wanted to fill. First, there's a localized LLM with 3 billion parameters. So what this does is it's localized in your computer, so it just stays in your computer. This means it doesn't have to access network. It doesn't have to meet another data point at which your information could be compromised. This is security. Also licensing, we would be theoretically doing this under a closed source. We don't want anybody to see the code as much as you don't want anybody to see the code. We want transparency between our software and your company. And this is why if you do purchase a license, then you will be able to vet it through your IT, through anybody that you wanted to. Furthermore, it's only around 3 gigabytes of storage. This counts as our deployability because we would be quantifying our software for so much less storage, about 1/3 of the fact that it would have been without quantization, for like 0.5% of precision. Lastly, secure encryption.
It does, as you can see in the video, read your transcripts, so you can go out and personally verify its work. It also, you input your information, your agenda or anything, and it will encrypt it, and it will also erase your meeting data after the meetings.
All right, so two of our most important key design requirements were performance and non-invasiveness. And to show you that our solution is feasible, we came up with a workflow that involves audio in, speech to text, AI processing, and optimized output. So we can show you here that there are already existing companies that use parts of this workflow. For example, Google, Informer, Moshi, and Lyra. And if we add up all their latency together, we can see that estimated it would take about 185 milliseconds, which is about a blink of an eye.
Now we'd like to give a short demonstration of our user interface. So let's say I'm a SANDIA employee and I'm about to join a Teams meeting. So when I press join now, our dialog box will pop up, and this will allow me to input what I want to whitelist and what I want to blacklist for this specific meeting. So first, let me whitelist today's agenda. This is stuff that I can definitely talk about, I will be talking about. Now for the blacklist, we understand that what's confidential for a specific employee is not necessarily changing day to day. So the user can define blacklist presets. Today, I'm not meeting internally in SANDIA. I'm going to be meeting with an external supplier. So let me choose that preset. Now, maybe this blacklist preset doesn't cover everything that I want it to for today. I'll just input anything else I want covered. We also have a slider for the strength of the AI. This means increasing the strictness will broaden the scope of the blacklist. Essentially, that means I have more restrictions on what I can and can't say. Now I'll press continue and join the meeting. Hi, Kevin. So we're talking, and let's say I accidentally say something that's on the blacklist. We understand that's not very common, but it's possible due to human error. So luckily, for peace of mind, we'll have a pop-up that says we automatically muted your microphone because you talked about a blacklisted topic. Now, I'd like to ensure that what was muted was actually what I wanted to be muted. I can show the transcript of what I said, and what's muted and what was flagged is highlighted. Now, after reviewing that, I can either add the topic to the whitelist, ignore this warning for now, or ignore this topic for the rest of the call. Let's say we keep talking and I go off topic a little bit. It wasn't explicitly defined in the blacklist, but it also wasn't explicitly defined in the whitelist. So I'll get an alert that says I talked about a non-whitelisted topic. I can either add that topic to the whitelist or add that topic to the blacklist after reviewing what exactly was flagged. Once I end the meeting, immediately what will happen is that whatever data was read and stored in the transcript will be wiped to ensure peace of mind not only from what you're communicating, but from what we're storing in our software.
Our business impact would be that we would reduce overall the company data leakage. And secondly, our LLM is completely localized and encapsulated, so there's no middleman. And thirdly, there's a near negligible delay and negligible delay and low latency. And all employees will have a automatic safety net whenever they join any kind of video communication.
What is our value to you? So we know, as well as you guys definitely know, there are high consequences for data breaches. The cost that can go into it, you're working on projects that are 10 million, 20 million, 50 million. The time that goes into it, we've heard through your employees that for each event like this, there's maybe like 6 months of a team investigating this. Your national security isn't even something that should ever be put at risk. And our estimated cost is a fraction of the cost of damage control, but the most important cost is the cost of your reputation, and you can't put a price tag on that.
Thank you. This has been Take Back.
Impressive presentation. Great job on the commercial over there. Talk to me more. This is like the next move, AI to the edge, inference at the edge, right? So
what are the compute requirements that we're talking about if we're taking it local? I can handle that. So currently, if you have been keeping up with news about like the iPhones and things like that, there is already an LLM model that's working on our phones that can run very, very quickly. And what's not to say that we can do the same thing, and especially if we put on a computer, each computer has even more compute power than that, will run very, very quickly. We don't have to worry about performance. It's not going to be an issue.
Add on, this kind of AI is also on your end chip on your MacBook.
Really like the element of video with a heartbeat that started getting louder and louder. I have felt that exact thing. I've done something else. That was really cool. But, I was on the time frame that you showed. It ended up, you said 25 milliseconds, but it ended up 185 milliseconds. So we're talking 0.2 of a second. If you all experiment, it seemed like that would be disruptive to a conversation.
I can take that. So that is around the speed of the blink of an eye. Our visual reaction time is actually 200 milliseconds, and we actually we called each other, and on our phones there is also a visible delay. There is always going to be a delay because unfortunately, there is no ideal world in which we could have the speed and the security, but this delay is really as small as it gets, and honestly, it's probably not even noticeable.
Asking a quick question, if you go back to the slide where you talked about that delay, some of the tools that you listed were cloud-based versus endpoint. Can you talk about how you plan on separating that so we don't end up losing data to the cloud?
Yeah, for sure. So we made this as kind of a model, as an example of what can be done with technology we have today. So to show you that it's feasible. But in actuality, when we're implementing this while working with y'all, it would be custom made. We would train our own model, our own optimized model, and with your unclassified data, of course, we can add context to it. So we would be taking out the cloud portion of it. This was running completely on device. There's no need for that, vulnerability point.
These are exemplars, not the actual building.
Yes, exactly.
What kind of a security plan? Is that a choice yet, or?
We haven't made that choice yet. Ideally, with working with you guys, it would be what you guys would feel most secure with, because we know that, of course, you guys already have your own. We've talked to your employees. We know you guys already have some of your own AI set in place, some of your own encryption, and it would honestly just boil down to what the customer wants.
Any other questions?
Mention that there's the cost compared to damaging our reputation. But what is the cost, and how much would it start to create and sustain?
Sorry, we have a slide here. So, just with our research over the last 2 days with what we were able to do, we did put together a kind of, how do you say, yes, an estimate of the cost it would take to ideally create this kind of stuff. And just a fraction of the cost for what you may possibly have to pay for those internal data breaches that happen so often.
And to add on to that, this is just the cost of development. So we would like to just mention that including service, since we'd be consistently updating this, the projected yearly subscription cost would be more, but we would work with the company to figure out how best to implement that.
All right, thank you. Team feedback, thank you. Team Flow. Come down, Team Flow. Where'd that clicker go? Oh, there it is. It's the down arrow.
Down arrow?
Down arrow. Yep, that one goes for today. Okay, hold on a second. Very good, judges. You're good. You're good. You're chilly. Okay.
Hi guys, we're Team Flow, the pipeline for success.
When the classification process at SANDIA National Laboratories is delayed, it not only hurts the lab's reputation, but also results in significant funding loss. Prolonged delays can foster an unproductive organizational culture and create major reputational risks that undermine other mission delivery in the future. This is Lance. He has been asked to classify a document. Now he needs to hand off to another reviewer. He waited just to realize that his team member is busy or on vacation. He finally handoffs the task, but also wasted time that he can be using to do other tasks. Hence, money lost. Introducing Flow. Instead of waiting for a classification review to be opened by your occupied team members, use Flow to securely and directly hand off the review request to the most available employee. Flow is an all-in-one system where reviewers can review and hand off. With features like side-by-side guidebook, AI word recognition, and a clear work timeline, now reviewers can effectively navigate between different classification files and their main task. This system improves work efficiency by sending data once into a pipeline that automatically routes it to the right destination based on vacation availability and current workload. This handoff is completed in under 2 days, which boosts efficiency by removing the need for workers to repeatedly check on pending documents and ensuring faster, more reliable delivery. Flow, the reliable way to minimize handoff delay to save time, stay productive, and use money where it matters most.
Yes, so after some interviews with some of the SANDIA employees, that we realized that the current classification process is very time consuming, and this leads to a problem where data classification process can lead to undermining the timely, time dependent, and mission critical decision making. So why do you care about this, and how does it affect the SANDIA as a whole, right? So in the short runs, 1 or 2 classification delays may not be a significant problem. However, as multiple delays accumulates, this accumulative delay will end up postponing the deadline for the general project, which as a result, it might fail to deliver the mission on time. And how does this affect the SANDIA? So one thing is about the reputation. If a mission is not completed in time, the project managers, project sponsors, such as the government agencies, will lose confidence and faith in this organization, which is something that is critical for the organization. Secondly, the delays in the project will overwhelm team members as they are overwhelmed by the approaching deadlines while still waiting for a response or the classification to be completed. And then lastly but not least, there is financial burdens. When classification process is delayed, there will be more effort to trying to figure out how to get this flowing, handing off each job to another through the classifier, which redirects their attention while they could use this attention to do other tasks.
Now we arrive at our 5 main design requirements. First, it's important that time is quickly used. If we have a reviewer who's waiting for a document to reach them, and the publisher is trying to get that document to them, it should take place within 2 days. Next, if a reviewer needs expertise or the time commitment and to aid them complete their review, the trade-off process of handing over that document should happen in one simple action or click. It shouldn't be a week of checking to see if that process has completed. Next, SANDIA deals with sensitive information, and thus it needs to be kept need to know. Next, number 4, let's say we don't want to stop the flow of work. We cannot stop. But if we have a document that's waiting in the inbox of someone who's out on PTO, work gets stalled. And finally, if we have different teammates that have different workloads, one has a very small workload and doesn't have to use their time to do very many activities, while another has a large workload. This is a very costly, effect on both the time and the talent that is available to the company to use?
Well, based on these 5 design criteria, we have this 3 potential solutions, one being the hub system, second full automation with AI integrations, and then the third one being the pipeline system. So to comparison, we decided to use the pipeline system as it's more financially feasible than the AI integration where you have to train the model over time and it's very costly. And it is better than the hub system where the system stores information and which it can be compromised if there's any external factors that come and took the documents which would be classified, which this cannot be happening with the pipeline system, which is temporary.
Next, after all this technical talk, let's play a game. Let's say, I'm sure a lot of us have dealt with marble tracks throughout our youth, right? And if I want to run the risk of getting my marble into the hole as quickly as possible, which side of the track do I start on? It's obvious, right? What side? I go straight in. Then I ask the question, why are we not doing this with our workflow? If we were to start with workers that are either out on PTO, have busy workloads, it may take a very long time for us to finally get our work done. And so then, let's think about the existing solutions that are in place for workflow at SANDIA National Laboratories. Let's say I need a document to be reviewed. And as the author, I'm sending it to someone. I might have to wait a while and they come back to me and say, that you're busy. All right, let's send it to someone else then. Well, it comes back. We realize after a week, they've been out on PTO. And finally, I'm going to get documents to someone who is available and get it published. But all this time has passed. Instead, let's use Flow. And through Flow, we're going to integrate things like APIs and existing tools like Outlook to assess PTO and availability so that we can get all of our reviewers prioritized in a list and then choose the most available reviewer to get the task done and published.
So this would be a 3D model of what we're actually talking about. So as you can see, the red dot will be the data transmitting between different reviewers. So as the first reviewer pass on their task, they're out of the loop, which significantly increase the labor. They can't do other stuff now. So what this pipeline system do is a temporary system that gathers different reviewers based on user input, which they can assign, and also they will gather more reviewers based on the reviewer data system where they look at the clearance level, the need to know, and their knowledge for reviewing the document. As you can see, as represented by the cylinders, those are the reviewers. If they're available, they're prioritized in the front of the queue, which when the data comes, they're the first one to be sent to. And if they don't, like for any chances they miss the thing, they will go to another person to ensure that this process is completed within 2 days.
Yeah, so this is the actual author view. So at the top, you can see whenever you're submitting the document, you put your title, the project title, as well as any sensitive hints, sensitivity hints that might aid the reviewer whenever they're classifying. And at the bottom, it's a clear timeline for the status of your review. So whether it's in queue, completed, being assigned, or in review, it just promotes a clear, transparent, and faithful, provides faith to the workers that their documents are actually being reviewed. At the top, you see the review request, and so this is the review. And the reviewer, whenever they get a request, they'll show notifications, and you can either acknowledge or deny. When I'm actually clicking into the document, it's in a web only and view only interface, and so you can actually screenshot or copy paste or download any of the documents, and it'll also be watermarked with the clearance as well as the name of the reviewer. And so whenever Well, like thinking about our design, really debating on how much AI and automation to use, but we did want to keep like the tediousness of classification like limited, and our time.
All right. Thank you very much, Team Flow. Judges, questions?
Can you talk a little bit about what's your cost model?
So the general idea approach we had is that the value of this tool comes from the fact that creating the system is going to be a one-time cost. Implementing the system, we anticipate that maintenance, because it is going to be something that should be simple solutions are effective, maintenance should not exceed cost compared to the benefits that you will reap in the time you're saving and the ability to move resources to where they're most cost effective and provide the most value.
I get the sense you've been watching SANDIA training videos. Every video that you produced. I think I heard you say that you were going to face queuing to reviewers not just on availability but also on busyness.
Correct.
Do you have a sense of how you're going to measure busyness for people?
Yes. Some conflicts we did think about is our system is focusing on the document review process. We are aware that lots of reviewers are volunteers who have other big tasks. So even though our system isn't going to have that information of what other tasks are doing, we're going to ask our reviewers to self-assess. They're going to publish their own status of how busy they are. And that will allow the system to consider not only the small scope of reviews, documents, and how lengthy they are, but also how they actually feel about all the other work that they need to do.
So I guess I'll ask, there's lots of workflow optimization and routing solutions out on the market. What differentiates you all from any of the other potential solutions that we might integrate at SANDIA?
A big difference is there's a priority on security, correct? The idea that we want everything to be in-house. We want to make sure that as we're providing information from one stage or one person to the next, that the data is not compromised. In this model, it is not stored in a hub in between spaces, but is effectively routed. And the routing process actually will happen as soon as you're requesting to send a document. Now, let's say that the recipient doesn't open the document, or it says that they are not able to work on this project. We're going to separate the idea of data assignments and data access so that they will not have access to the documents until they've accepted the task, thus promoting the need-to-know ideal. They're not going to revert, they don't need to see.
In your requirements, you stated a handoff in 2 days. 2 days seems pretty lethargic for a modern AI-based system. Did you get that from your SANDIA mentor, or how did you drive that requirement?
Our time requirement was based on some of the personal interviews we did, based on the fact that for an overall process, it could take 1 to 2 weeks. And we also heard that for several instances where documents are exiting the company, external facing, that you would still need multiple levels of review for different purposes, for different expertise. And so we wanted to make sure that we're still not compromising the need for that human input for all those levels.
You used your mechanical flow model for your distribution as an analogy for your distribution of the work. How are you updating availability as you make assignments?
Well, as we heard that there is a procedure that when you go out for a vacation, you fill out a slip and then give it to your HRs. So what we're trying to do is have the HR update that like frequently. So we can use that API to integrate it to our system to use that to assess their availability on vacation wise. And for their workload capacities, that will be self-assessed.
Okay, so if you assign them a document, they would re-self-assess? Because then they'll have to take on that as part of their workload.
Yes. Yes.
One more quick question. All right, thank you, Team Flow. but not least, Team Lockout. If you guys need to move that table, go ahead. If you guys need to move that table, go ahead. Who's got the clicker? Clicker here. Clicker here. Arrow down. Arrow down is going forward. Arrow down. Hold on a second. Hold on. Very good. Judges, we're looking good. Team, we're looking good. All right, whenever you're ready.
You've heard that sound before. Now, what if you never have to hear it again?
In the morning, when I'm getting ready to leave my house, I need to be cognizant about where my different electronic devices are. Make sure, okay, my personal laptop, make sure that my Bluetooth is off, my earbuds,
Every day at SANDIA, employees enter limited areas with a heavy mental checklist. AirPods, watch, phone. Even one slip, a Garmin watch or a forgotten phone needs reporting, calling multiple people, and extra stress. The result? Lost time, anxiety, and a constant feeling of walking on eggshells. Employees have told us, when my kids call me, I want to be there. But instead, they walk 5 to 10 minutes to overheated phones in their cars, or depend on pagers, a technology from the 1950s. Pagers break, cost hundreds, and can't deliver the communication modern employees need. It's outdated and unfair. That's awesome. And here's a contradiction. Laptops with radios and storage are allowed inside, but phones, even work-issued, are not. Employees see the inconsistency. Security sees the risk. Both sides are stuck. Our solution is Lockout, an RFID-triggered system that flips a phone into a secure pager mode the moment you enter a limited area. Wi-Fi, Bluetooth, and cellular shut down automatically. The device becomes receive-only, safe, compliant, and reliable. Workers reduce risk, lower anxiety, and finally feel normal. At SANDIA, employees want security, but they also want to feel human. With Lockout, we bridge that gap, because in the end,
I just want to be able to go to work like any other employee.
Howdy. We're Lockout, and we're aiming to do just that. In talking to our mentors, the main problem we identified is that these pagers simply aren't efficient. The only thing you see on a pager once you receive a message is the phone number. Then workers have to spend 5 to 10 minutes at a time just finding a landline phone to see what the message is, which can either be a genuine threat or their kids calling them from home. This is an issue, as it not only wastes energy, it wastes time as well, and time is money. These pagers are also expensive. They break often, and they're expensive to replace, which is something we will touch on later. These pagers also make your workers vulnerable. Taking out a pager in public can be a security risk, as these people, as only high-level clearance individuals receive them.
All right, what are the guidelines? What's the criteria? So we want to minimize security risk, meet NSA guidelines, remove additional devices, and be cost efficient. So our first option was an updated pager. Although they maximize security and obviously meet the NSA guidelines, unfortunately, they're not cost efficient and you require additional devices, right? You have your PED, personal electronic device, and then you got your pager as well. So our second option is private network. So it's cost efficient because you just have to replace your current network. No additional devices are required, but unfortunately, security risk, right? You got bugs and malware and just not efficient. And then we have Lockout, our solution. Obviously, it checks all the boxes, and additionally, it's a software you can download
on your own device. And it doesn't require any additional steps, and or you don't need multiple devices.
Now, what is Lockout? Now, Lockout is a secure lockdown application that is installed in every employee's personal electronic device that is triggered and activated through a reader. Basically, it's going to start out with the initial home screen, and it's going to go into a work mode. This work mode is basically going to be very customizable, where it only allow certain allowed applications to be implemented. So it will allow, for example, communications like email, Outlook, and calendar, and it will disable any risky apps like social media and cameras. Now, for the implementation, it will remove Wi-Fi and Bluetooth. Now, it's going to work where we have the near-field communication readers installed in the limited area entry points and the secured space entry points. As they enter through the entry points, they will pass the ID reader. After they pass that, they will then use their device and scan it through the NFC, near-field communication reader. And from there, it will trigger a command that basically allows the initial installments of the logout to run. So it's a command that runs it constantly, and it won't leave until they leave an exit point. If they enter the limited area, it will disable Wi-Fi and Bluetooth. If they enter the secured areas, it will disable all full cellular shutdown, where we have no data transmission, or it will let only a one-way communication activate. Then we will have exit points, where after they leave the exit points, it will then disable the cellular shutdown, but at the same time, it's allowing the limited area command to still run. This will obviously disable the Wi-Fi and Bluetooth, and as they leave the entry point or the exit point of the limited area, it will then kill the command and let the phone or any device run freely as normal.
Right, so that's how it works from a technical perspective. Let's talk about how it's going to affect your day-to-day life and your employees' day-to-day life. Say I'm a worker walking I'm on a secure military facility installation. I'm approaching a limited area. I badge in like I do every day. And as soon as I cross this threshold, all I have to do is pull out my electronic device, scan it, and Wi-Fi and Bluetooth is now disabled. Now I can enter the limited area, no security risks, no threats. Now from approaching a secure area, it's going to be the same process. I'm going to take out my CAT card or any government issued ID. I'm going to scan in. As soon as I scan my device on the second scanner, it's going to go into full lockdown mode, making this a one-way receiver and no transmitting radio waves.
Okay, as you likely know, limited access areas often have thousands or up to even 10,000 workers on campus, because this is for on campus. So let's take a conservative estimate of like the amount of people that have pagers. Let's say 10%. That would approximately be 1,000 devices, 1,000 pagers that cost around $129 with a 2 to 4 year lifespan. And well, we know that from interviews and trying to page a 5-year pager, which unfortunately did not go through. And so as you can tell, they're unreliable, and our estimate cost for that is about $18,000. While on the other hand, lockout, being more secure and more efficient, is only $12,000, which averages around $10 per device, as MDMs, which are mobile device management, usually approximate around that price. But speaking of which, besides that, the actual cost of the cognitive load on people, the stress, the nightmares they have of things in their pockets, waking up and and literally we heard stories of reporting dreams. Like that's some mental workload that you have to put in as well.
Okay, so finally let's touch on how it's going to impact your facility and your employees. Communication. Not only are we improving communication or improving communication in a detailed way for work and for employees' families. They're going to get one-way communication abilities while keeping your area secure. We're improving security. These devices not only enable one-way communication, but also detect any other Bluetooth or NFC radio frequency waves that will deny entry upon detection. Feasibility. It's feasible, it's practical, it's super easy. All you have to do is walk into work like a normal employee, scan your device, you're locked down and secure with one-way transmission. Efficiency, it's very efficient. It's going to save you time, your employees time. And employee morale. This generation is glued to their phones like a bunch of kids. I myself am, and my little brother and sister. So improving retention and accessibility to their personal devices will help with employee retention and morale. Also, I want to note on security, we can partner with Apple OS systems. Most of the time, you can't change the actual operating system, but Apple does allow third-party vendors who partner with government defense agencies to change the actual OS and emit all radio waves and frequencies. So we're Lockout. I would like to thank the judges and the Malloy staff. They did an awesome job. I'd like to open it up for any questions.
Great.
So you talked about taking out your device and putting it in your to turn off the different layers.
Yes, ma'am.
One of the most common aspects we have, and I will self-admit about 2 months ago I did this, is you forget you have your Apple iWatch on, or you forget you have your device in your pockets. Right. So how are you addressing that?
Okay, so in that case, let's say I swipe into work, right? Now I'm approaching the point of entry, right, a POE. Now with this scanner, I'm going to scan my device. Now Bluetooth and Wi-Fi are disabled, but I have a Garmin watch on. It's got Bluetooth. So access will be denied and a red light will flash saying, please disable Bluetooth and Wi-Fi. Let's say I'm going into a secure area, right? This is the main security concern. I badge into a secure area, walk into the POE for a secure area, scan my device, and it picks up on my Garmin again. Oh, now I have to store it in an outbox. But my personal device is activated and locked in one-way transmitting.
So once you're into the deepest area on the multiple as you're scanning each way through, it seemed like at that point everything was turned off. And so how does it become a one-way? I might have missed. How is it one-way communication? It's like just a brick at that point.
Right. It is, but only in one direction. So it can still receive information, but you can't transmit. The OS operating system actually blocks that.
I was going to ask something related to that. I know on the latest Apples, you can receive SOS text through GPS system one way.
Yep, and satellite.
Is it a common feature on all other phones now?
It is pretty common, but overriding the OS and partnering with Apple, we can disable any outgoing frequencies, radio waves, NFC, BLE, Bluetooth frequencies. It'll all be disabled.
Yeah, and if I jump in on that, especially like iPhones, it's a lot harder since Apple controls all like the little details, but it feels like Android, right, which is the second most common. It's a lot easier to turn off like NFC completely on Android. So, like always.
Is there any data sharing between your two phones? One is your physical access credential, one is your phone credential. Is there any data sharing between the two, or is the phone one essentially standalone?
It's essentially standalone. It just activates.
Yeah,
it's an activation code for the software.
Yes,
So what I hear is you've got an application that everyone will need to download onto their devices, personal devices as well as professional.
Yes, that's
So basically, it's going to be a client-server system where every employee will either go through HR or a training module where they have to get this manually installed in every device, and it will be registered. And when they register it, they will gain digital credentials. The digital credentials will then be read by the server system, or the secure server system as well. So every time it would go through the NFC, near field communication readers, it will then be read and then activated the command.
So the credential that prevents an unauthorized person from just having the software on their phone and bringing a phone that still won't work.
Right.
It's not credentialed.
Yeah, basically Lockout will only allow it in certain registered devices, so not anybody can have this downloaded. It needs to be manually installed in devices that they can only authorize.
Have you thought about, or are there plans to work with the different PED vendors to ensure that even though you're one-way listen only, that you don't have AI agents learning from that listening?
Right, data collection.
Right.
Yes. So again, with the OS operating systems, when we do input our software into that, it will actually prevent data collection and transmission. It can only receive incoming signals.
One more question. All right. I guess that's it. Thank you. Thank you all. Thank you all. Now, the judges will probably take a little bit of a break. And then the judges are going to meet in this classroom back here. The rest of the teams, David will be the QBR code for the survey punched up right here. Professor Fano. He's on. He's behind you. Oh, he's hiding. He's hiding back there. He's hiding back there, right? So, students, please fill out the survey. Liv will be going around to each team asking for 2 teammates to please for some quick interviews to help us with some Instagram posts on how wonderful. Okay. After the judges are done, we are going to meet all back here, and then we're going to go into the main stairway and take some pretty pictures, right? And please don't fall when you do that, okay? Take some pretty pictures. We'll come back here, and then we'll start with People Choice Awards, and then we'll do the big checks with 3rd, 2nd, and 1st place, right? And then kick you out where you need to do the most. You probably have some homework to do, right? Yeah, you probably do, right? Okay. All right, let's get started. All right?
Alright, if I can have 2 members from every team come with me, just make sure you scan the QR code. Desert highway.
Hey everybody, excuse me, just real quick, in case you didn't hear Liv, 2 team members from each team come outside and let's do a quick video, knock that out after you capture the QR code, okay? 2 members from every team join Liv out in the hall. Thank you.
Yeah.
That's
Yeah, we'll know about the volunteer one of the Yeah. Are you gonna join them? You get up there. You want to go? Yeah. What's the way to cure James, I like your.
Oh, thank you.
I don't have any money. You can launch your startup.
I like that.